Hi guys, my name is Kristen Urquidez and I'm a science teacher here locally in Kern County. And today I'm bringing you a special episode of Science Sunday because Halloween falls on a Sunday. And so what a perfect excuse to kind of do some science relating to the holiday that it falls on. So today's Halloween inspired Science Sunday is called Disappearing Pumpkins. And you'll find out why in a little bit as we set up our investigation. So the science skills that we're going to practice today include asking questions and defining problems. We're going to carry out an investigation because those are always fun to do hands-on inquiry investigations. And then we're going to interpret our data that we collect from the investigation. And then finally, determine what we learned from our investigation and how can we teach others about what we learned. Some of the big ideas or cross-cutting concepts that we're going to cover are cause and effect, stability, or when things are not changing very much. And then the opposite of that is obviously when things do change. And then the third one that it seems like we always cover is this idea of energy and matter. And that's really, it makes a lot of sense because matter makes up our entire world around us and us, inside of us as well. So we're going to talk about those two things. So our question today is, how do different liquids affect how fast a candy pumpkin dissolves? So we're not talking about a real pumpkin. This is a candy pumpkin. And when you put candy in liquids, sometimes you come back later and the candy seems to have disappeared. So that's where our disappearing pumpkins title comes in. And so Drew and Connor are going to join me today to set up our experiment and collect our data.
Hi, I'm Connor. Hi, I'm Drew. And we're going to do a Halloween science experiment today. Yes, with pumpkins and candy. I like candy. I like candy.
I know you like candy. A lot of people like candy. And
yeah.
That's one of the favorite things that they like about Halloween, right? They get to dress up and eat candy.
Yeah.
So we're going to do a little bit of an experiment today because we have these little candies that look like pumpkins, right? We're not eating these because we're doing science. We don't eat in science. We don't eat in the lab. Do you guys know what candy is made out of?
Pineapple.
No. What else do you think it's made out of?
Sugar.
Sugar. Candies are made out of a lot of sugar.
Sugar dissolves.
Well, we're going to see. That's what we're going to test.
Okay.
So when you eat food or you drink something, your body not only is getting liquid if it's drinking, but if you're eating, the whole purpose is to get what for your body? What does your body need? Energy, right? Your body needs energy to function. And so whether it's candy or piece of fruit or pasta or whatever it is you're eating, even pineapples, it's giving you energy. And so when your body is breaking something down, like let's say we eat the pumpkin candy, it's going to break this down in your stomach. It can't leave it whole like this. So one thing we want to test is how quickly does something like our candy pumpkins break down, or in this case, we're going to dissolve them and see how quickly they dissolve or break down in our different liquids. So we've got a couple different liquids. We've got coffee because I thought this one would be good because when people drink coffee, like adults, when they drink coffee, the dentist says, make sure you brush your teeth really well because you don't want it to stain your teeth. So I'm thinking this might do something. And this one's like super caffeinated. So maybe caffeine or coffee has something that might break down the sugar. And then I've got vinegar because people use vinegar a lot for cleaning. Mm-hmm. So I thought, well, maybe that could break it down. We've got soda, and that's another thing the dentist doesn't like you keeping on your teeth very long. Have you ever heard the dentist say like soda rots your teeth?
Yeah.
Yeah?
Well, I don't have soda a lot.
No, but that is some concern that people have. So I thought, that might do something to our candy. Then we've got vegetable oil, and we also have water, and I did warm that up a little bit, so if it does do anything, it might a little bit quicker so we can watch it.
And
So I want you guys to make your predictions. Which liquid do you think is going to dissolve or make our candy pumpkins disappear the quickest? Water?
Yeah,
One vote for water?
I think it's going to either be the vinegar or the oil, because I don't know. I remember like last year in like science class, I remember learning about like dissolving and stuff, and I think it had something to do with like vinegar that dissolves, or maybe oil. So I think it's either one of these.
Okay, so here's a close-up look at our little candy pumpkins, so you can see what they look like to start. And what you guys are gonna do, you can each take two. I'll do the coffee one.
We get to eat them?
No, we don't eat in the lab, right? Got a whole bag here. So speaking of the bag, if you look at the nutrition label, it says there are 24 grams of sugar in 4 of these candy pumpkins. That's the serving size, okay? 24 grams. And on the ingredient list, it lists sugar, corn syrup, and dextrose. So all of those are some version of sugar in different forms. So what our body does is it breaks it down to get a specific sugar called glucose. This might take a while. We're gonna like time lapse it a little bit, okay? So what we're gonna do is we're just gonna gently kind of drop it down and make sure it kind of goes under the surface. So go ahead and do your 2, drop them in. And now we're gonna do a time lapse and let them sit for, I don't know, what do you think, like 30 minutes? You wanna see? Should we check back? Let's check back.
20 to 30 minutes.
20 to, yeah, let's maybe do 30 minutes. And we'll come check back in and see if we see any noticeable difference in our pumpkins, okay? All right, we'll be back.
Yep. Wow.
They look a little bit different.
Yeah.
So it's been almost 30 minutes, but I thought we'd come back in and do some observations before we pull them out. So what do you notice from what's...
The coffee one looks gone.
Okay.
The water looks
Well,
like
I don't think we're not sure because we can't really see through the coffee.
But the water looks like it absorbed it because it wasn't orange before.
What do you mean by absorb it? What do you observe?
I don't know, the water looks orange from the pumpkin.
Yeah,
And then it's died down. This did nothing.
The oil didn't appear to do
it doesn't
anything?
It doesn't.
So the water changed color, and what happened to the size of the candy?
It shrunk. It looks like it just like got ripped up, like if it was like a dog chew toy.
Okay.
And the dog got.
Okay.
Yeah. Well, the coffee looks. Oh wait, no, the soda. It looks like it turned into like weird.
Okay, so it changed colors. It looks brown, right?
Mm-hmm.
And where do you notice about where the candy is in the cup?
That one floated to the top.
I think it's the only one floating.
And then the vinegar, it looks like it doesn't even look like it looks like an orange. Like it looks like a fruit.
It looks like it's also changed color, but all the orange is at the bottom. Mm-hmm. Whereas the water, it's like throughout the water cup.
Top of the water, it's like no, but like this one, it doesn't look like a candy. It looks like an orange when you peel it.
Okay, an
it's
orange.
Kind of like that whitish orange.
Okay, so what we're gonna do, we're gonna move all these back. We're gonna carefully scoop out each of the candies and lay it in front of the cup so we can compare them a little bit more. Okay, so I'm gonna give you each a spoon. Carefully scoop out as carefully as you can. Yeah, right on the paper there.
Oh.
I think, did that one just dissolve? So we'll just go like that. There we go. That one's very soft. Good job. There you go.
Whoa.
And for comparison, this is how we started.
Oh.
See, it's still there. Okay, I think that's it on yours, Drew. Mm-hmm. All right, so.
What about the coffee? The coffee didn't really do anything.
Okay, so the coffee looks the same.
Yeah, oil looks the same.
Oil looks the same. Okay, so those didn't seem to affect the candy very much at all.
The vinegar a little bit.
Okay.
I would say the soda, it looks entirely different. I would not know that's a candy. Mm-hmm. That looks like a bubble or like a lump of like.
Yeah.
I do not want to eat that. Yeah.
Okay.
Ew.
Yeah,
this one, the oil didn't do anything. The water is like just. I think the water did was the most effective.
And I said water.
So the water, there's a little bit left. This is definitely a little bit solid still. This is not solid, like at all, right? So
maybe the soda is probably.
The soda, I think, dissolved the candy the most.
Yeah. But the water shrunk it.
Water was probably a close second, and then vinegar a close third behind the water.
And then coffee and oil did nothing.
Didn't seem to do anything to
I mean, the coffee looks like it covered it, but like it doesn't.
Yeah.
It did anything. The coffee.
So inside your stomach, do you know what's helping your body break down your foods?
No.
What's in your stomach?
Acid?
Yeah, stomach acid. Acid is very acidic. And so if you looked at these substances on a pH scale, it makes a lot of sense that our very acidic, like soda is very acidic, is gonna break apart those particles.
What soda is it?
It's just Coca-Cola. Like the stomach acid in your stomach, which that's its job, to break apart the food that you're eating, whether it's candy or fruit or vegetables or bread or whatever.
Or something healthy.
Or something, yeah, definitely for something healthy, because it's going to pull out the energy. When it breaks it all apart, it's able to get the energy out. Okay? So by this being very sugary, we were able to see which liquids could break apart or what looked like dissolve the candy, a lot into. You're not going to eat that one. So the one thing you can do at home or at school, you could do this exact experiment and see if you get similar results or something different, or you could choose different liquids. So if you guys were to do this again without copying the same liquids, what's one other liquid you would want to try?
Pineapple juice.
Pineapple juice. That's an interesting one, actually.
Orange juice?
Orange juice?
Milk.
Or milk? Okay, those are very interesting choices. So you've given people at home, or if they're at school,
ketchup.
Ketchup, that would be interesting.
What about honey?
Honey? Yeah, there's so many more choices besides just these. So if you're gonna do it at home, definitely maybe do some the same and some different ones.
You could even try different sodas.
Yeah, you could try different sodas to see if the flavor or anything makes a difference. Maybe try a clear soda. So a lot of fun. You could also do this with different candies. So this one is very sugary, almost completely sugary, but some candies have peanuts in them, right? Or caramel or different ingredients. So it'd be interesting to see if those dissolve any differently. So you could also change up the type of candy.
You could also do apple juice.
You could do a lot of different juices. Okay, so as your reward for doing great science, you get to enjoy, now that we're done with the lab, the candy, okay? All right, thanks for joining us, and we'll see you next time.
Bye.
All right, so now we've done our experiment and collected some data and made some observations. I want to go over some of the, little tidbits of information to help us put some of these pieces together and figure out what we've learned. So this is a couple of pictures here. One is of the packaging for the candy pumpkins, and in the experiment, we talked about the ingredients, right? And there's a lot of sugar in candy, and that's part of the reason it tastes really good. And in this nutrition label, there's actually 3 different kinds of sugar, or 3 varieties of sugar that are used. So definitely a lot of sugar in the candy pumpkins. And one form of sugar, the form that your body actually really wants, that it's going to use to actually get the energy for your cells, is called glucose. And you can see there, the different letters represent different elements that make up this particular molecule. And those elements are carbon, hydrogen, and oxygen. And the lines between them represent bonds, or where those atoms are sticking together, kind of like glue. And what happens is when something comes along and you have a chemical reaction that can break that bond between 2 atoms, the breakage of the bond releases energy. And the energy is what your body uses to power its cells. So when you have something that has a lot of sugar in it, and if you are eating it, the stomach acid in your stomach is going to work to break down that food, whether it's a pumpkin candy or something else. And when it breaks apart that food, it releases energy. Okay. Now, we didn't put these pumpkin candies into our stomach. We put them into different liquids to see if there were other liquids that would break apart this sugar, essentially. And so what we found out is that there definitely were some interesting, patterns in which ones dissolved or broke apart the candy and which ones did not. So this next graphic here is a pH scale. And all you need to know about the pH scale is it goes from 0, or in this case, it's starting at 1, but technically it's 0 to 14. And right in the middle here is number 7. And this one is labeled pure water, okay? And we did have water. Now, our water was a little bit, we did a little bit of something to it. We warmed it up. So it wasn't boiling, but it wasn't cold water either. And that plays a role in how fast the candy broke apart for sure. So just to give you guys some reference, the pH of the soda is a little bit around 2.5 or so. Same thing with the vinegar. And those were some of the top 3 of which ones dissolved our candy. And then the coffee was a little bit more towards the middle, not exactly, but about a 5. And obviously there are other things in coffee, cream and milks and things. So the exact pH of the coffee drink that we used may not be exactly right there. Water we said was 7. And then oil is a little bit more than that, like 7.5, 8 or so. That kind of gives us some perspective and to make some interesting observations about pH and how it may affect whether a liquid is able to dissolve candy, the little candy pumpkins or not. So this is just something interesting. Now, we said it's the breaking of bonds, and that is definitely all about chemistry. When it's the breaking of bonds in your body or chemical reactions in general that are happening in your body, we actually call this biochemistry. We combine those two things together. So this is kind of an interesting mix of both kind of straight chemistry as well as biochemistry, because we're talking about how it relates to living things. And so even though we were using candy and putting them in cups of liquids, it definitely has a tie-in with how your body works with your stomach and the stomach acid and how it helps accomplish the goal of getting energy out by breaking apart foods that you eat, including candy pumpkins. So definitely this does not give you permission to eat your entire stash of candy that you collect tonight. But it does help us learn a little bit about what we're getting out of the food that we eat, including candy. We do have to put that in perspective that, we have to eat everything in moderation, can't overdo it too much. There is definitely a stomach ache being a possibility, eating too much sugar. But it's kind of interesting to know that your body is getting something out of every piece of food that you eat or liquids that you drink. So your challenge, if you'd like to do this at home or maybe with your classmates, is to set up your own investigation with different liquids. Drew and Connor had some great suggestions for other liquids. I'm sure you could come up with some additional ones as well. And see if you find any other liquids that do a good job at dissolving or breaking apart candy, pumpkins, or whatever candy you can find. And then the other option is actually using different candies. Maybe it's one that has nuts or caramel or marshmallow in it, or maybe it's more like a fruity candy. Definitely be interesting to see how different candies also react in these liquids. So I hope you have a wonderful and safe Halloween, and can't wait to hear if anyone comes up with their own challenge for the disappearing pumpkins. We will see you next time.